So I wanted to start, I gave you guys kind of a simple view of the next big eras here, and we tend to think of these as kind of these big hurdle problems. All right, first step, big hurdle problem is data. Second step, big hurdle problem is process. Third step, big hurdle problem is trust. So let's kind of stick with that framework a little. But before we jump in there, William, could you tell us a little bit about SRI? Because again, I think it's a fascinating organization.
Sure. SRI International was started by Stanford University. Used to be called the Stanford Research Institute. It's more than 60 years old. And it is a very unusual kind of company. It's an R&D company. Our business is research and development. The other thing that's a little unusual about it is it's a nonprofit. So what that really means, especially if you're coming from outside the United States, what it really means is there are no shareholders. So we have to make money like any company, but by law, the money has to go back into our mission, not into the pockets of investors or shareholders. So we do many things. I run the information and computing sciences part. That's about 250 people. We have an AI center, speech lab, vision, cybersecurity, and we do research for the United States government and for commercial companies all over the world. The other thing we do is spin off companies. So Siri started as a spin-off of SRI. It was acquired by Apple. And earlier today, I mentioned the Da Vinci machine. That's a telerobotic surgery system, also a spin-off of SRI, Intuitive Surgical.
So fascinating organization, someone to keep track of. Really just interesting to think about some of the projects that they're working on. Anthony, I'm sure many of us are familiar with D&B. I think we see the ubiquitous D&B number. But I wonder if maybe you give us just a short summary of kind of your role with D&B and kind of what keeps you up at night.
Sure. So Dun & Bradstreet, many of you will know it from either credit reports or sales and marketing, getting lists and understanding companies. We keep track of businesses all over the world, over 300 million businesses. Those businesses come from different countries. There's different writing systems. There's different laws. There's data governance. So the data thing is a very big deal. We've been doing big data since forever. Dun & Bradstreet is about 1841, don't do public math, 177 years old. We started before the Civil War, helping companies discover other companies. We're still doing the same thing, except now we're doing it on the internet. The world has changed a lot in that time, and at the same time, these business problems haven't. So my role is to bring the new. So I don't think we should have an AI strategy. I think we should have AI in our strategy, right? If we're going to do customer segmentation, we can do it the old-fashioned way, or we can use unstructured data, segmentation, classification algorithms. So I bring the new stuff. I'm not part of any line of business. I'm sort of part of every line of business. So I get to have a lot of dotted lines and make a lot of trouble all over the world. And that's about it.
So Anthony, let's stick with that all over the world. I mentioned that there's actually a real geopolitical dimension to data if you're an international company. That's something you live every day.
Absolutely.
How are you guys coping with that? How is that kind of manifesting itself in your business?
Well, I think we have to be very careful when we use terms like good, bad, right, wrong. It's a big world out there, and what we consider intellectual property, what we consider coercive behavior, what we consider to be extortion, what we consider to be collusion, those definitions change all over the world, even fraud, right?
Yep.
So you have to be really, really careful when you bring your epistemology, your belief system to another country. There's a reason why you have two ears and one mouth, right? You have to listen a lot, and you have to understand why people think what they think before you go insist that this is the right or wrong way to do it.
Right. William, we hear about data as being that first ugly hurdle. Is that, kind of consistent with your experiences as you work through projects at SRI?
Yes, especially the ugly part. So we're working with our customers or clients' data. We, of course, generate our own data, but that's not very interesting. We're solving problems for various customers, again, government or commercial. What I always say, and I think everybody here probably understands this, the data is never what you think it is. There's always something wrong with it in the sense that it's been corrupted in some way, or what it's purported to be, what it's purported to cover, its currency,
Absolutely.
the number of fields, just isn't reality. So, so there's always this discovery process. I will add, however, that one of the things we're working on, and other researchers are as well, is problems. So the whole data-driven deep learning type approach has become extremely popular for very good reasons. It's producing spectacular results. But it's not the only story. Sometimes you don't have the data, or it's way too expensive to get the data, and we're working on what you do then.
Right. So let's stay with that for a minute. I think, you know, as we look at this, everything now is kind of handcrafted, hand curated, and we can almost see this world where data is just another menu in my DevOps environment, right? I have low, no code. I go out and I call containers. Those containers invoke algorithms. Those algorithms go and hunt down data. Is this all a pipe dream? How long between here and there in your mind?
Well, I think we're a long way from there. In fact, one of the issues that I like to talk about is that that environment you were sort of sketching, and those words that you were using are the results.
Are fighting words.
Well,
yes, they are.
They're the results of years of development and software engineering practice and principles and teaching, and from what I've seen, people can stand up and correct me, AI implementations are way behind on everything that you just said.
Right.
The interfaces between different AI, let's say deep learning based systems, things that we would, in a normal software sense, study very hard and look at exactly the interfaces and use common protocols and have RESTful interfaces and all that, basically doesn't exist. And these things knock against each other, they can corrupt each other's data, and it's a big problem. So I think we're way far away.
Yeah. Please, go ahead.
Yeah, let me just add, if you just think about this as a scientist, what do you have to believe? So when we both, I'm just going to guess here, that when we both did our dissertations, we went to a physical library, at least for part of our research. Today, you know, there's some portion of the room saying, what's a physical library? Right? So the world changes in bizarro ways, and we just sort of let that happen. It's part of what you were saying this morning. So the one I look at is the Internet of Things.
Right.
A couple of years ago, it wasn't an Internet of Things. It was an Internet of Things connected to the Internet. All of those things went back to an application, and they checked in, and they shared their data, so the data got localized and standardized, and all those other things that end in "ized." Now we're moving to autonomous devices, edge computing. Those things create data at the edge or in the environment. They don't necessarily share that information back. There's data synthesis. It is not hand-curated. It is machine-curated at billions of times a second. And so the ability to understand all of this data in its entirety, it's an environment that is independently discoverable anywhere it is, and yet unknowable in its entirety.
Right.
And then the lawmakers and the litigants will expect us to have known what was knowable, right? We need some new nouns and verbs. Yeah. We don't have the right word. All those words you use don't work in that new environment.
No, that might be the
And I
quote
think
of
that's
the
your
morning.
problem, right?
We need new nouns and verbs to talk about AI, and that is, I think, part of the challenge here. All right, sometimes, I am someone that is rarely at a loss for words, just, I mean, to be honest. And there are times where it just makes you pause. It makes your head hurt. It challenges your fundamental thinking about how does work get done, what's right and wrong, how do I decompose a problem, how do I solve a problem. So we see this maybe next step of task level AI pretty clearly. All right, we find a business opportunity, we identify the data sources and maybe some of the algorithmic processing that needs to happen to take advantage of some new knowledge, and we apply it. And we get these thin kind of task level improvements. How do we begin to string them together? Have you had projects where you've done that for customers? Yep. Because to me, the thing that's really interesting here is once we stop talking about data and we start talking about process, well, now we're really in the business of outcome as a service, and that changes everything.
So one of the things that we do is we steal shamelessly from other disciplines. So as an example, when you study economics, you study decision elasticity. How wrong do you have to be before you would make a different decision?
Right.
Well, that applies to data science, right? When you study hermeneutics, you study the understanding of like progressive decomposition, taking a very big unsolvable problem and breaking it down into smaller problems until you can solve one. Well, we can do that, right? So what we have to do is take these formal things that we've learned and apply them, because lessons learned aren't lessons learned unless you learn from them. The other thing I would say is that the opportunity cost here, the cost of doing nothing, the cost of saying, well, most AI projects aren't really succeeding, so we'll just wait until these things work better. The cost of doing nothing is you slide backwards at a much faster rate. So I'm sorry, you got to play anyway.
Right. So William, I'm sure that you guys have had some best practices as you've tried to kind of broaden the scope of the projects you've done. I wonder if you could share any of those with us.
Sure. So what immediately came to my mind was robotics, because you were talking about sort of task level competencies that are AI based. And a robot, here I mean, sort of think of the science fiction view of robot, but dumb it down. I'm not talking about the things that work on assembly lines. That has to combine a lot of different kinds of AI capability. Perception, planning in terms of where it's going to move, it's going to move, planning in terms of the tasks that it's being done. So the answer, which is, again, not surprising to anyone, is over the years, and robotics is pretty old. I think we had the 60th anniversary of Shaky, which is the famous robot. So, so there are architectures that define the interactions of these pieces. And again, that's been worked on for decades. The question is, what are the right architectures in an enterprise setting? And it's going to be different for different enterprises and different for different applications that will then take those task level competencies and combine them. So we're figuring that out.
Right. So one of the things I find challenging, and certainly so many of my customers find challenging, is the black box-like nature of so much of what we talk about here. It's not quite as bad as quantum computing, but almost.
Quantum computing is just physics.
Yeah, well, right, kind of. But we get into situations where we have regulatory compliance issues. We always talk to customers about this idea of either transparent or explainable AI.
Yeah. Or
trust is certainly a huge issue in this market. And I wonder if you could talk maybe a little bit about how you're trying to create environments that are transparent, that are explainable, that do engender trust.
So I work a lot with regulators around the world, and this conversation comes up a lot. I do not think we need AI DPR. We don't necessarily need a set of regulations that regulate the AI, because that definition is so poorly understood and so strange. Depending on who you ask, you'll get, you ask 17 experts, you'll get 43 answers to the question, what's the definition of AI? And now you're going to regulate it. So we need to regulate, as you said, we need to regulate the behaviors. We need to have ethics. We need to have, what do we believe? Why do we believe it? And whether that black box is something that you can open up and understand. Good luck understanding what a qubit really is. But if you can open up the black box and understand that there's some sort of neuromorphic algorithm there, and it's reached a conclusion, and that conclusion is testable according to a set of data, that's no different than a drug, where you understand the outcome of the drug. So we don't go down to the quark level to understand what the drug is doing. We need to think about the behaviors around data, around how we're using the AI, what we're calling AI. I don't know what an AI refrigerator is, but the whole point of just thinking about these technologies as automata that produce output. It's the input and the output. Were you allowed to use the information that you used? Did you do anything unethical, amoral, all of those things in the processing, the creation of the algorithm? Right? If I use adversarial AI, I feed you data to cause you to make the wrong decision. Don't say stupid AI, say criminal behavior, right? So that's how we have to think about it.
So no,
I don't think you're ever
Gibson Turing registries every time.
Yeah, we're not going to get to fully explainable AI. It's going to get worse, not better. We're not moving towards Star Trek. We're moving towards the Jetsons. Everything sort of kind of works, but not really. That's the direction we're going. Sorry.
Oh, I love that. So William, how about trust from SRI's perspective? How big an issue is this when you work with your clients?
Well, first, I mean, I would underscore that we don't really have explainable anything.
Right.
So
Very good.
I came here on an airplane. That's
Yeah.
a very complex device. It's in a very unstable environment, and yet, in some sense, I say that I would trust that. I mean, you get into elevators. So getting into an autonomous car doesn't seem to me to be that big a leap along that. That said, there's some level of understanding of what those systems are trying to do. And what's interesting is what they're trying to do is pretty limited. Autonomous cars are very sophisticated in terms of understanding their environment and path planning, but they're not very sophisticated in terms of the many, many different things that they can do, ditto airplanes, elevators, et cetera. So one of the things that we're going to be facing with the AI systems, not so much of the present but of the future, is that they can do lots of different things in lots of different ways. And then the trust goes more toward how we trust one another as human beings, because we have that characteristic too. So I think about how we learn to trust anything. I mean, as I said, we don't have explainable anything. That applies to people too. You can't explain why you did something, or, I mean, you can make up an explanation, and people are pretty good at that, but that doesn't really explain what happened. And yet we learn to trust each other. And we do that by becoming familiar with how we behave in certain situations. And yes, of course, it's behavioral and output, but it's not completely predictable. So how do you form a model of someone? This is what we're really talking about. That
Digital twin.
Non-digital twin. That's reasonably predictive and that you can trust.
Well, thank you so much. This has been really interesting. Please join me in thanking our panelists. Thank you, Anthony. Thank you, William.